very early days right now, but it's a very, very exciting technology, and hopefully I can show you why. And that's why I've called this How the World Wide Web is Transforming Telecommunications. Can you hear me? How the World Wide Web is transforming telecommunications, and WebRTC really is an instrument of that transformation. So what is it? Well, WebRTC has started its life as an open source, free project, adding real-time communications to the World Wide Web. It's being standardized by the World Wide Web Consortium, the same people that standardize everything to do with the web. Members today include Google, Apple, and Microsoft, the big ones, as well as, you can see, Cisco, Oracle, and other big names. To put it very simply, in a nutshell, WebRTC is a set of building blocks and open standards that will give us high-quality video and voice communications on the World Wide Web. So we already have multimedia in HTML5. We've all probably used it. Less and less these days do we need fancy Flash plugins and things. You can just go to a website and play voice, play video. What's not built into HTML5 though is bidirectional audio and video. So what I'm trying to show in this picture here is your phone and your web browser, and that could be video phone too. Right now today we have Chrome, Firefox, Opera, all supporting WebRTC out of the box, both desktop and mobile, so that's a lot of coverage. Currently, plugins are needed for Explorer and Safari, but I believe that will change. So, really, WebRTC is about webifying telecommunications, or if you want to put it the other way around, it's about adding telecommunications into the web. So, we've been talking a lot today about customer service, about contact centers. Well, imagine a contact center with voice and video to a live person at the other end, just by going to a web page. Already people are doing things like recording studios from a web page. Part of WebRTC that enables that is that it allows full quality stereo audio. Bring your own device is an important factor in this, because if anyone brings a device to work, you don't really have control over what's on that device, but you know it's going to have a web browser. Online university, online schooling, another very exciting possibility for real-time interaction through voice and video. And there's some pretty cool devices. What I've shown here is an exercise bicycle that's actually available today. It connects to the internet, allows you to take part in interactive gym classes from your home. So let's quickly look at what WebRTC isn't. There's a lot of misconceptions, it's been hyped a lot. So it's not a replacement for voice over IP. Whoops. I think I've got to switch slides. It's not a replacement for voice over IP. It was never meant to be that. It's complementary, and I'll show you why now. It's not a replacement for SIP either, because it doesn't actually incorporate any signaling protocol in itself. It's not Skype, but it does share quite a lot of characteristics with Skype. And no one's really claiming it's a solution to world peace. However, WebRTC complements voice over IP, works together with voice over IP, because it brings voice over IP into the web domain. If you look at this little picture here, you'll see how a web app can add a WebRTC and SIP to the normal HTTP to get interactive voice and video. I think the important point here as well is that WebRTC allows us to take voice and video out of the specialized device, out of the voice over IP phone or any other kind of specialized device, and bring it into a completely generic web browser world. So it'll certainly help us talk about all these. Okay, so this is a bit where you can sleep, but I'll go very quickly through it. WebRTC started its life in 2009. Perhaps arguably started its life there, but the Google Chrome team realized that something is really missing from web browsers, and that's real time. 2010, Google acquired two companies, ON2 and GIPS, and from that they acquired some very good voice and video codec IP, and they decided to go ahead and open source those and provide patent indemnification. Anyone wants to use it for free. Whoops, that was not meant to happen. Let's go back one. Right. 2011, the first open source project for WebRTC was released, and that code is still available today at that URL, and that's really what forms the engine inside Chrome. The standards continue to evolve. Oh, what I should have mentioned as well is that that's when we started to see other companies, Ericsson, Cisco, and others getting on board, and the working groups starting to happen. 2012, first WebRTC conference expo held, and Chrome 23 actually released WebRTC inside. I don't know if anyone used it. 2013, we start to see the real deployments. Firefox and Chrome both working and interoperating with WebRTC. And 2014, we see Microsoft, Apple, Orange, Samsung, others on board, at least in some way, and over 300 vendors already active in the market. 1 billion WebRTC capable devices, because most of you with Android phones already have WebRTC capability on those phones. So let's look quickly at what's driving the adoption of WebRTC. I may be repeating myself, but I think the important point is that the web user experience up till now has been lacking that interactive real-time voice and video. WebRTC directly fills that gap. Software is migrating rapidly, as we've seen a lot this morning, to cloud and web-based technologies. Bring your own device works best if the application is web-served. Bandwidth, which is obviously a prerequisite for any of this to work, is just getting cheaper and more readily available, and pretty much ubiquitous wherever we are. And WebRTC directly addresses security and connectivity challenges and concerns that the World Wide Web presents. So it's designed to run in the web. So really convergence, which is what this has all been about today, is what's driving WebRTC, and vice versa. So is it really useful? Well, yeah, I mean, the telephone has been around a long time, and remembering a long number, putting it into a special box and talking to someone at the other end was a great idea 100 years ago. But now we have the web. And this is the way that we communicate, this is the way we interact. It's different from telephone, it's individualized, it's always on, it's rich in context. You make a call, you want to make a call to a company that you're buying goods from. So we add WebRTC to the web, to the browser, and as I've said many times, we're now adding voice and visual communication right in that environment. So yeah, the telephone's been useful. Now add video and rich web content. It's certainly going to be useful. Let's look very quickly at what's different about WebRTC compared to traditional or legacy voice over IP compared to Skype. Now once again, it's not really to replace these, but it does share some similarities. I'm not going to go in detail through this, but I think what you'll see is that WebRTC has taken, from day one, it's taken two things very differently from what voice over IP and perhaps Skype has. It said let's use open standards, and it said let's go from peer-to-peer as far as possible. It's also got security built in stack from day one. All right, so there's a bit of a geek on the top left there because this is a really geeky slide. But this is pink, green, and blue are the building blocks that you'll find inside your Chrome, Firefox, Opera browser, whether it's on the desktop or on your mobile. And these are the bits that do the magic. So acoustic echo cancellation, pretty important when you're using your laptop or your mobile device in speakerphone mode. It's already there, it's part of WebRTC. NetEQ is what they call their adaptive jitter buffering and packet loss concealment. Codec, the recommended voice codec is Opus. That's combined the best of breed of a couple of different technologies to provide a codec that does better than G79 at low bandwidths, does as well as MP3 at higher bandwidths, and full quality stereo audio, and does everything in between. Then we can put our audio and video together into one stream, something that's often been a problem to get synchronized video and audio. That's been taken care of. Also encrypted at source. So hopefully, to some extent, work around the privacy issues. And then the other big issue for anyone who's done voice over IP is connectivity. It's difficult to get peer-to-peer streams working. And ICE, Internet Connectivity Establishment, is a set of IETF standards that have come together to provide the best possible ways of breaking through firewalls and establishing peer-to-peer communications. And then another thing that all modern browsers have is something called WebSocket, which allows you to go beyond the normal request response for HTTP and have a two-way communication back to your browser. That's very important for getting signaling working in WebRTC context. Okay, so let's look at WebRTC end-to-end. This looks similar to any other voice over IP picture, except for one thing, peer-to-peer audio and video. So almost universally, when SIP is deployed and SIP and voice over IP are deployed today, the voice streams go to the provider and come back again to the other endpoint. WebRTC tries to get peer-to-peer going as far as possible. There is a fallback to being routed through the cloud if necessary. I think we can look quickly at the sort of deployment of this. Endpoints connect to a web service. Web service delivers HTML5 content, provides signaling, provides assistance for internet connectivity establishment, and we end up with a secure stream of audio and potentially video between the peers. This is your very simplest form of WebRTC. Let's look what happens when we throw WebRTC into the legacy world, as I call it. So now we introduce gateways, we introduce WebRTC-enabled PBXs. Today, if you download the latest asterisk, it's enabled for WebRTC. You can talk to another WebRTC endpoint. And other vendors out there are adding WebRTC to their products. So we can envisage a network where we've got rich content delivered from the internet, and as part of that content, we're able to establish bi-directional video and audio streams from peer-to-peer or from an endpoint to a gateway, where we can connect it to the existing telephone networks. So some of the opportunities around this, well, remote workers. So you're sitting at home, sitting in an internet cafe, you're anywhere. You connect to your home office, and you immediately on your PBX. Integrating your customer service support center into your web page. Carrier services, voice over IP services being resold through various consumer level web apps. CRM, conferencing, the list goes on and on. So just a little bit more detail. We all know web services and HTTPS, we use them every day. We need a signaling service. SIP is definitely still a very valid signaling service in this this environment, but WebRTC doesn't mandate any particular sequence type. Gateways we just looked at, that allows us to get into the legacy networks, and then the support for internet connectivity establishment. Those are the things that have to be present in the cloud to make WebRTC work. I've shown firewalls here because WebRTC is designed to work from behind firewalls without any special configuration of firewalls. So let's just quickly look at sort of an animation here on how a call will be set up using WebRTC. So we have user A, we have user B, they're both behind firewalls. I should probably mention as a prerequisite, they're both connected to this web service, so they're browsing a web page and perhaps logged in as a user. Stun request and stun response. Well, that's part of the internet connectivity establishment. It allows A to find out what its public IP address is. Now that it knows that, it can send a SIP invite, including that information about its public IP. That goes to B. B says, okay, well, I'm going to accept this invite, but I don't know my public IP. It does the same thing. Net result is it's able to send its response, and we have a SIP all set up, but no media yet. Now that I know the public IP of B, or from A, or I know the public IP of A from B, I can send a stun request to my peer. And provided the response comes back, we've actually tunneled through the firewall, and we've got the firewall holder to our end-to-end speed. So that, in a nutshell, recently is how WebRTC is able to deal with in a firewall environment. Right. Very important part of this WebRTC is how it's going to play with mobile. And the answer is it's going to play well with mobile. So right now today, if we look at the mobile market, quarter one 2014, 81% Android, 15.2% iOS, and a little bit of OS. That's the reality of mobile device OS market share today. We don't know where it's going. That's what it is. Android today, Chrome, Firefox, Opera, all WebRTC. Very likely you'll be able to connect to WebRTC service from your Android device today and it just works. iOS, unfortunately not quite the same point, but there are SDKs, so if you want to make an iTunes app that supports a WebRTC service, that is possible. Windows Phone, not yet, but it has to. I think mobile and WebRTC together probably offer some of the most exciting possibilities for this technology. So just looking at that graph, we have 96% reach, given what I've just told you of mobile today with WebRTC. Lastly, let's just look at 6 key benefits of WebRTC. It's free and open source, so it really is about communication and democracy. It has security, good security built in from the ground up. It offers excellent quality of communications by using the most advanced codecs and backed into the network. It takes telecoms out of the realm of specialists and makes it accessible to millions of web developers. I just want to dwell on that for a moment. Telecoms has been a pretty specialized area for many, many years, probably forever. Whereas the web has come from a different framework altogether. And I think I've heard it said there's orders of magnitude more web-savvy developers out there than there are telecom developers, literally millions. So it certainly sets the scene for an explosive future of innovation in telecoms. It enables peer-to-peer comms, which is obviously the most efficient way of getting real-time data connectivity. And it taps into billions of ready-made endpoints, as I just mentioned in the previous slide. And as you see on previous slides, is able to interoperate with various networks. So I think I'll move quickly through that, and what I'm going to try and do here is slightly risky. Please forgive me if it doesn't work, but because we're in a Wi-Fi environment here, I'm going to attempt